Hello all, this is your Maverick here. We are going to solve previous year questions of Engineering Mathematics 3 from the topics Karl Pearson's coefficient of correlation denoted by small r, straight line fitting, and lines of regression. The first question, a bivariate dataset is given for which Karl Pearson's coefficient of correlation, that is small r, needs to be calculated. So let's write the formula of small r, which is n times summation xy minus summation x into summation y, the whole upon square root of n times summation x square minus summation of x the whole square into square root of n times summation y square minus summation of y the whole square. Here we need to calculate summation x, summation y, summation xy, summation x square, and summation y square. So let's calculate all of these. Hundred into 30 is 3000. 200 into 40 is 8000. 300 into 50 is 15,000. 400 into 60 is 24,000. 500 into 70 is 35,000. For x square, 100 square is 10,000. 200 square is 40,000. 300 square is 90,000. 400 square is 1,60,000. 500 square is 2,50,000. 30 square is 900. 40 square is 1,600. 50 square is 2,500. 60 square is 3,600. 70 square is 4,900. Now let's calculate the summation. 1 plus 2 3 plus 3 6 plus 4 10 plus 5 1500. 3 plus 4 7 plus 5 12 plus 6 18 plus 7 25 250. 3 plus 8 11 plus 15 26 plus 24 50 plus 35 85,000. 1 plus 4 5 plus 9 14 plus 16 30 plus 25 5,50,000. 9 plus 16 25 plus 25 50 plus 36 86 plus 49 13,500. So let's substitute all these values in the formula. N is the number of observations, that is 5, into summation xy is 85,000 minus summation x is 1500 into summation y is 250, the whole upon square root of 5 into x square is 5,50,000 minus summation x, that is 1500 square into square root of 5 into summation y square is 13,500 minus summation is 250, so 250 square. Let's put this value in the calculator. 5 into 85,000 minus 1500 into 250 upon square root of 5 into 5,50,000 minus 1500 square 5 into 13,500 minus 250 square. So let's calculate the value, which is equal to 1. So value of R is equal to 1 over here. In this method, we found that we have to deal with many zeros, and some at times it is quite tedious to deal with many zeros. So we make the use of the fact which we know, Karl Pearson's coefficient of correlation is independent of change of scale as well as independent of change of origin. So let's divide the observations in x by 100. So this will be change of scale. And let's subtract observations in y by 50. This will be change in origin. Usually, we take greatest common divisor or highest common factor, GCD or HCF of the observation to be divided for change of scale. And we take somewhere the mean value of the observations or somewhere the value of which comes approximately in the middle to subtract for change in origin. So let's calculate x by 100. 100 by 100 is 1, 200 by 100 is 2, 300 by 100 is 3, 400 by 100 is 4, 500 by 100 is 5. 30 minus 50 is minus 20, 40 minus 50 is minus 10, 50 minus 50 is 0, 60 minus 50 is 10, 70 minus 50 is 20. Now let's calculate x square, that is 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, y square minus 20 square is 400, minus 10 square is 100, 0 square is 0, 10 square is 100, 20 square is 400, x into y. 1 into minus 20, minus 20, 2 into minus 10 is again minus 20, 3 into 0, 0, 4 into 10, 40, 5 into 20, 100. Let's calculate the total. 1 plus 2 plus 3, 6 plus 4, 10 plus 5, 15. Minus 20 plus 20 minus 10 plus 10, all these gets cancelled and this summation of y will be 0. 1 plus 4, 5 plus 9, 14 plus 16, 30 plus 25, 55. 400 plus 100 is 500. Again 100 plus 400, 500. 500 plus 500 is 1000. Minus 20 minus 20 minus 40 plus 40 is 0. So summation xy is 100. So in this alternative method, R can be calculated as n times summation xy minus summation of x into summation of y, the whole upon square root of n times the summation x square minus summation of x the whole square into square root of n times the summation y square minus summation of y the whole square. Let's substitute the values. 5 into summation of xy, that is 100, minus summation x 15, summation y 0, whole upon square root of 5 into summation x square is 55 minus 15 square into square root of 5 into summation y square is 1000 minus summation y 0 to 0 square. Now let's enter this into the calculator and find the value of R. Now let's move to the second question, where we are going to fit the straight line y is equal to a plus bx for the given data. Required equation is y is equal to a plus bx. Normal equations to find the values of a and b. For the first one, we directly take the summation of required equation, that is summation y is equal to n times a plus b times summation x. For the second one, we multiply by independent variable x and then we take the summation. So it will be summation xy is equal to a times summation x plus b times summation x square. Now let's calculate the values of summation y, summation x y, and summation x square. 5 into 11 is 55, 6 into 14 is 84, 7 into 14 is 98, 8 into 15 is 120, 9 into 12 is 108, 10 into 17 is 170, 11 into 16 is 176. 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 54, 9 square 81, 10 square 100, 11 square 121. So let's calculate the summation using the calculator. Let's go to statistics mode. Select y is equal to a plus bx. Then enter the values. In front of 5 we have 11, 6 14, 7 14, 8 15, 9 12, 10 17, 11 16. Press AC, save this, go to options, two variable calculations, where we find summation of x is 56 and summation of x square is 476. 56 and 476. Then again, summation of y is 99 and summation of xy is 811. 99 and 811. Normal equations can be written as summation y, that is 99, is equal to n times a. N is 7 as there are 7 observations. 7a plus summation x, that is 56b. Then summation xy, that is 811, is equal to summation x, that is 56 times a plus summation x squared, 476b. Solving the normal equations simultaneously, we can either solve the equation simultaneously or directly get the values from statistics mode. AC option, when you go to regression calculation, we get the value of a and b. So value of a is 8.714, is 8.714, and b is 0.678. 0.678 is the required equation of line is y is equal to 8.714 plus 0.678 x. Hope you all understood both the questions. We shall continue the third question in the next video. Thank you.